for a few years now, I've been collecting these little boxes at the local dollar store. So yeah, they're just ideal for some types of projects. They're not weatherproof, so you know, you've got anything that involves water or whatever, that's going to be an issue. But there's a lot of other projects which they're just perfect for, and they're only like $1 or something each, so pretty good. So they come in all sorts of different designs, just plain ones as well. And I thought I'd show you a couple of projects that I have done, and in one case I'm still working on them. So let's have a look at these two. This one here is a clock and temperature indicator. So it's got a long history, this one, and I'll have to do a separate video and blog about this whole project, because you know, it goes back a long way. There's a lot of design changes. I don't think it's finished in that regard. I still have a lot of things I'd like to do with it, but basically it does nothing. It just sits there, and then when something warm walks past, a cat, a dog, or preferably a human, the PIR sensor will pick that up and then just kick in and display firstly the time, but then also the temperature using the internal components here of the RTC. So that's a pretty standard RTC there. This is the, let's see if I can zoom in a little bit on that one. So this is the PCB that I've rigged up. So it involves an Atmega 88A, and you can see the form factor there. And not too much else, a few other components. This here is for changing the time, you know, if you want to alter the time, minute and hour, etc. And then you've got your display, which is a TM1637, I always forget that, and your PIR, of course. And then it just sits in one of these little boxes and does its thing. It's got 3 batteries there, 3 AA's on the back, and your little coin cell battery there to keep track of time. And it'll just sit there quite happily for months on end. It depends. I mean, if it's a high traffic area, then yeah, you know, you'll have to change the batteries more often. I'm actually at the moment thinking about converting a couple of these to a 5-volt external power supply. But really, at the moment, it's just about the box. And here's another one, which I thought we'd spend a little bit more time on. And the genesis of this is a question I had. I'm a school teacher, and I had a question at school saying, can we have an altimeter? And I thought, yeah, we can certainly have an altimeter. So we've got a on-off switch on the side here, and at the moment it's reading 116, which is meters above sea level. Now, in order to actually do anything with this, you need to know either a fixed height. So for instance, I know that I'm currently 235 meters above sea level, or if you knew what the air pressure was at sea level, then you can set that. So on the side here, there's a rotary encoder. So when I push that, it'll say what is the pressure at sea level, and then you just change that. So let me just increase that, for instance, and then press that. Now that's decimal place, so it's not just whole numbers, but decimal place, and then you can see it's gone up. So the air pressure at sea level here is above 105, knowing that this has to be 235 to indicate the actual altitude. So let's go to 1015. Yeah, it's a bit of a slightly strange rotary encoder. I need to put some debounce stuff in there. 241, okay, so slightly above where it needs to be. So let's go back and change that to let's see, and 230. That's about right, but if I wanted to get it exact, I would change the decimal place up by a couple, and that's pretty accurate to where we are actually at the moment. So what's inside? Let's have a look. So hopefully we can see everything here. So firstly, there's the display. So that's the TM1637, and then this is the bit that's doing all the work. This is a BME280, and that's measuring air pressure. Can also measure temperature, but not at the moment, just air pressure. And then it's going to a little Arduino Nano, which I think I can zoom in on there. Let me just see if I can do that. Yeah, so the light's not great, but anyway, there's your Arduino Nano, and we've got a 9-volt battery coming in there. So obviously there's a voltage regulator on the Nano itself, and then you've got your rotary encoder on the side, and that's pretty much it. I'll put the code on the blog, and then we might do a little bit of a trial, just drive down my driveway actually, which is probably about a 20-meter drop, and see how it performs. Of course, you know, the other thing about this is that if the air pressure changes in the course of, you know, a journey or what have you, then, you know, naturally enough the altitude will reflect that. So it's a bit of a moving feast sometimes, but you know, in terms of the little science project that they wanted done at school, that worked out fine. Terrific. Let's give it a whirl. Right, here we are at the top of the driveway, around 237, so about a couple of meters above where the workshop is, and just heading off now, so it should start to drop as we drop. So you can see a little bit of flickering there associated with the camera picking up the same frequency as the display, the TM1637 display. Nearly at the bottom of the driveway now. I think I said it was about a 20-meter drop, and we started at 237, I think. So what's that, around 17 meters? And now just going out onto the road. So we go up to a little rise first. One thing which I didn't say when I was looking at the box was that I've actually drilled little holes in there as well. But having said that, we are inside a sealed car. So at some point I actually asked the driver to open the window up, and that does change straight away in the altitude as a reflection of that. But oh, that's better. But yeah, just going up and down these little rises, and that's reflecting in the altitude shown. So not a bad little device. The BME280 is fantastic, and very simple code, which you can see on the blog. And we've used this quite a bit as we're moving around, just to get the lay of the land, basically, find out where we are altitude-wise. Seems to be pretty accurate with what we've seen. Not a bad little project, and did get some use at school, so good result. That's the circuit working. See you next time.